So let's have a look at the gradient of a straight line. The gradient of a line that lies between the point x1 and y1 and x2 and y2 is change in y over change in x. So y2 minus y1 over x2 minus x1. This is the same as y1 minus y2 over x1 minus x2. As long as y is on top and x is at the bottom. And if you start with this coordinate, you must start with this coordinate on top and bottom. And if you start with this coordinate, you must start with that coordinate on top and bottom. Okay, you can't mix y's and x's together. So the x and y value for the one coordinate must be there, the y and x value must be there. It must be y's on top, x's at the bottom. It can't be y and x and y and x. Alright, another way to put that is the gradient between a line AB that lies between the points A and B is change in y over change in x, where you have B first and A second. Or this gives you the same answer as if you have A first. And then just a little bit of theory. If M is positive, then the line is increasing. In other words, going that direction. If M is negative, then the line is decreasing. In other words, going in that direction. If the line is vertical like this, then the gradient is undefined. You can try and work it out yourself if you'd like. And if it's horizontal like this, then the gradient is 0. Okay, so let's have a look at a few examples. Let's determine the gradient of the following lines. Okay, so here is the first example, and let's look at the solutions. So line 1 is going through two coordinates, but we don't know what that coordinate, the y-intercept, is. So what I'm going to do is I'm going to work out the gradient, which is change in y over change in x. Okay, and I am going to write it in one line in an attempt to have you see both the calculations and the sketch at the same time, but you are not allowed to do this in a test. In a test, you must have 1 equal to per line, and you must move this down. Alright, so it does not matter which coordinate you start with. I'm going to start with this one. So it's the y value and the x value, and then minus because of the formula. Okay, and then the x value for this one is -4. So the reason that it's negative and negative is because the coordinate here was already negative. Okay, and then, apologies, I made a mistake here. So y value -2 minus the y value, which is 7, over the x value, which is -2, and the x value, which is -4. So I'm going to repeat what I said. The reason that this is negative and negative is because the negative comes from the formula over there, and that second negative comes from the fact that there was already a negative in the coordinate. So you see this one is -7 because the 7 wasn't negative in the equation. Okay, so let's work this out. -2 minus 7 is -9. -2 plus 4 gives you +2, and that is your gradient in this case. Alright, then for line 2 looks like this. This is the equation y equal to 2. And we said that if it's y equal to 2 or y equal to a constant, in other words, if it's horizontal, then the gradient is 0. We do not have to calculate this one. The gradient is 0 if we know our theory very well. And then this line over here, line 3, where this is x equal to 6, that's the equation of the line. So the gradient is going to be undefined. gradient is undefined. Alright, in the next video we'll do gradients of parallel and perpendicular lines.